Okay, good morning, Professor David De Los Reyes. Okay, I've got the long video format for my topic for this morning. This will be differential calculus. It's just a simple problem. I just want to emphasize the importance of the so-called differentiation formulas. Okay, let's proceed. We are given a problem. Find dy dx. We are given y is equal to a dynamic, what they call this a fraction, the product of quantity x plus 2 times quantity x minus 4 all over the quantity x plus 3. So actually we are given a fraction, okay? Or it seems we are given y as a function of x, and the problem is asking for just dy dx. So the purpose of the problem is actually to determine if you know how to differentiate a fraction. Or as simple as that one, okay? Uh, I will not give you a complicated one for the meantime. It's just this one. So I will test if you know how to differentiate a fraction, that is a numerator over a denominator. Okay, let's proceed. To bring out the solution, I rewrite the given problem, the given function, that is y as a function of x. And to, what you call this, simplify the calculation, okay? I will try to expand first the numerator before I will proceed with the differentiation. I will try to expand first because if we are differentiating and it involves a product, it will become more complicated if you don't expand first. So for me, okay, I will expand first the numerator. So I will leave n equal to, this n here is a numerator. So the given numerator is actually the product of the quantity x plus 2 times x minus 4. If you don't want to expand it, okay, it's fine. But in the simplification process, it's longer, right? So what I will do is that I will expand first the numerator. So when I proceed with the differentiation, okay, it's only an expanded form, so I could proceed immediately with the differentiation without expanding. Okay? If we try to expand, this is the product of two binomial, right? Okay, x plus 2 times x minus 2. Okay, we are now on the fundamental operations, the multiplication of two expressions, right? So if we try to expand this one, we will use the so-called distributive law. I am now discussing for the meantime also algebra because I got a topic algebra from some other topics, right? So if we try to expand this one, it will be x times x will be x squared, 2 times x will be 2x, minus 4 times x will be minus 4x, plus 2 times minus 4 will be a negative 2. So that involves algebra. Okay, we are not yet differentiating. So as you can see, algebra is actually very important because if you don't know how to expand and you do not know how to, what they call this, taking the product of a negative and a positive, that's another thing. Okay, but if you know it, okay, very good. So the n now, after the simplification, it will be an x squared. We combine similar terms. Okay, combining similar terms. That's a fundamental operation. A 2x minus 4x will be a negative 2x minus 8. This is minus 8. So the expanded form of the numerator is actually x squared minus 2x minus 8. If you do not want to expand, it's fine. But for me, I want to expand first. Okay? Then I will rewrite the given function now. Therefore, y now will be equal to the expanded form of the numerator, which is x squared minus 2x minus 8 all over x plus 3. Okay? The problem is asking for dy dx, and we know that uh, dy dx, okay, from the basics of differential calculus, that will be the derivative with respect to x of y, right? So to compute for dy dx, we must have to differentiate the right hand side with respect to x because we are given y as a function of x and we are given y as a function of x. Okay, so there's no problem with that one. So therefore, I rewrite this one. This is the expanded form of the numerator all over the given denominator x plus 3. Therefore, taking the differential of both sides or the derivative with respect to x of both sides, the derivative with respect to x of y will be equal to the derivative with respect to x of the given function, which is x squared minus 2x minus 8 over x plus 3, close bracket. What you do on the left, do it on the right. And the derivative with respect to x of y is actually the one we are looking for, right? That is actually dy dx. The one we are looking for, dy dx. Right? And for the right hand side, okay, apply now your knowledge of differentiation. This now falls under a quotient. Okay, so it seems we are taking the derivative with respect to x of a numerator over a denominator, both as a function of x. This is maybe another g of x, right? So if we try to recall the formula on how to take the derivative of a quotient, it will be the denominator times the derivative with respect to x of the numerator. Oh, this is not a complicated one. It's just basic, right? Minus the numerator times the derivative with respect to x of the denominator all over the denominator square. We are given the numerator, right? X squared minus 2x minus 8, and the denominator is simply the value x plus 3. So if we try to follow this, what will come out will be the denominator is x plus 3, right? Times the derivative of the numerator. Okay, it will be a 2x minus 2. The derivative of x squared will be 2x. The derivative of negative 2x will be negative 2 times 1, or just simply minus 2, minus 0, or just simply 2x minus 2. This is where the reason why I expanded this one already, because if we try to take the derivative of this, it's more complicated because you are taking the derivative of a product, right? But in here, since we did already the expansion, you just proceed immediately with the differentiation. So it will just be simply 2x minus 2. The derivative of 2x will be, x squared will be 2x. The derivative of negative 2x will be negative 2 times 1 minus 0, or just simply 2x minus 2. Right? So what's next? Minus the numerator, minus the value of the numerator is a quadratic equation, so we place it in one quantity, x squared minus 2x minus 8, closed quantity, right? This is a negative sign, so just beware, put a quantity, okay? Because later on, you change sign if you try to expand this one. Times the derivative of the denominator. The derivative of the denominator, the derivative of x is actually 1. And the derivative of 3 is 0, or 1 plus 0, or just simply 1. All over the square of the denominator. So in here, if we try to expand this, it is much simpler now. Because if we haven't taken the, what you call this, expansion of the numerator, okay, you are taking the derivative of a product. It's more complicated thing, right? So if we try to expand this one, distributive law under college algebra, it take the first one times the value 2x minus 2 plus 3 times the quantity 2x minus 2. We just expand, right? Or you could place this on your scratch. But if you are taking the board exam and they want you to bring out the complete solution, it should be something like this. Minus. Since this is 1, I could remove this one now. And I can proceed with removing the quantity. Right? So if I will remove the quantity, if a negative 1 times a plus x squared will be negative x squared, a negative 1 times a negative 2x will be plus 2x. A negative and a negative, this will not be plus. A negative and a negative, this will also be plus. So this quantity here is very critical because there is a negative sign over here. Okay, expanding this one, this will be 2x squared minus 2x, 6x minus 6 minus x squared plus 2x plus 8. Then try to combine similar terms. That's again algebra. Try to combine similar terms. 2x squared minus x squared will be x squared minus 2x. Cancel with this. What remains for x will be 6x. This is 6x. The pure constant term is negative 6 plus 8. Okay. Negative 6 plus 8. This positive is greater than this negative, so the sign will be plus 2. All over the square of the denominator, x plus 3 quantity squared. That will be our final answer. As simple as that one, if you expand immediately, but if you don't expand, you will be expanding over here. It will be longer on the numerator, right? So what I did is that I expand first this one. So when I expand, I simplify the numerator. It is much simpler. Okay, that's it. Good morning from Los Angeles. This is Professor David J. De Los Reyes.